All right, good morning. Hopefully you guys just finished up watching the 8.1 odd solutions. Hopefully you did well on those and you got the whole worksheet done on your own and you did well. All right, so yesterday we did notes for 8.1 where we introduced transformations, and the one we focused on yesterday was translations or slide. That's usually the easiest and you guys do pretty well on that. Today we're going to talk about reflections, and of course you want to think about reflecting in the mirror. If you are looking in the mirror, and this is your mirror, okay, if you're looking into the mirror, well, your reflection is the same distance away from the mirror on the inside, if you will. So you're this far away from the mirror, so your reflection actually appears to be that far away from the mirror as well. Okay, so that's what we're going to be covering today, reflection. A reflection is a transformation that maps all points of a figure the same distance from a central line of reflection. A reflection is a flip. The shape retains rigid motion. The image can be named using the following notation. Okay, we're going to get into that right now. So, real quickly, I'm going to try and match up this triangle here. Just give you something a little bit to look at. I won't even actually try that hard, to be honest with you. I'm just going to create a triangle. Okay. If I can rip that guy off real quick. Should have had this already made up. Not a pretty triangle, but if I think about a reflection, we're going to take this triangle here and we're simply going to lift it up and we're going to flip it over here. That's what a reflection is. We're literally flipping it over, boom, but it's going to end up in the same spot. Now when we do a reflection, we're basically moving it horizontally across our line of reflection, okay? So the line of reflection is here, so we're going to move this guy vertically, or I'm sorry, not vertically, we're going to move him perpendicular to the line of reflection. So if we could draw lines perpendicular to the line of reflection, we could say, well, how far is this? Well, R prime is going to be right there. And how far is that? Well, K prime is going to be that far out. And L is only that far away, and so L prime would be right there, and we would have our triangle. Now, obviously, I did that without measuring. But if this is our line of reflection, okay, our points will move the same distance from the line of reflection. This, say, is, I don't know, let's just say 10 spaces, so this would be 10 spaces. This is 3 spaces, so that would be 3 spaces. And that's how we get that reflection. Okay? All right. So, when we do a reflection about the line to create our image, this is, remember, our pre-image, and this is our actual image. All right, now this is interesting. Sometimes your figure will go through the line of reflection, and that's okay. He's just going to end up on the other side. So, again, I'd like to draw lines that are perpendicular to our line of reflection. Now, this isn't perfect, obviously. I'm just giving you some rough examples. For that far, I'm going to need to move that over a bit. And this guy is actually going to end up on the other side. Obviously, those lines are not perfectly perpendicular, but you can see if C moved that far, then C prime will be over here. And if A moved that far, then A prime is going to be probably over here. And B is this far, and you'll notice he moves to the other side. So there we have B prime. And then we end up with our new triangle that has just been reflected over line M. And if I straighten that out, it might look a little bit better. If we straighten that, make that horizontal, or that line M vertical, maybe it looks a little more normal to you. Okay, so let's learn how to do this. Let's learn how to write the rule Now most of the reflections we're going to be doing are going to be over the x-axis and the y-axis. Towards the end we'll get a little trickier, maybe do some other lines, but for the most part everything's going to be reflected over the x-axis and the y-axis. It makes it a little easier to find the horizontal and the vertical lines. Alright, so what we're going to do here is when we do our rules, we're going to stick to this basic rule writing like this, where we start with the beginning, the original, and what we're going to end up with. Okay, so let's see what we're doing. A reflection is rigid motion and preserves size and shape. Going to be very important here for us. All right, so how are we going to reflect this guy? Reflect about oh, it didn't give us. We're going to say the x-axis. Oh, okay, I'm sorry. This is notation. We don't use this notation, but a capital R means rotate, or reflect. I'm sorry, reflect. And we say reflect. They would have the description here, what this is, triangle RST about the x-axis. So we're going to reflect triangle RST about the x-axis. Okay, so we're going to write our rule up here. If we're going to write it above the x-axis, let's look what happens. So remember, we're reflecting it over the x-axis. So x-axis is right here. So perpendicular 3 would go down, S would go down 3. So that means we're going to go down 3 more to write S prime. T is simply down 1, so we go down 1 more to write T prime. And R is down 1, 2, 3, 4, 5, so we have to go down 1, 2, 3, 4, 5 for R prime. Okay, we reflect it. The x-axis is horizontal, so we reflect it vertically. So 3 down vertically, down 3 more. Down 1 vertically, down 1 more. Down 5 vertically, down 5 more. And when I graph this, we get the same triangle. It's rigid motion, so it's the same size and shape. We just reflected it or flipped it over the x-axis. So let's take a look at the rule here. So we had S at 2, 3. Okay, S was at, here it is, S is at 2, 3, and now it's at 2, negative 3. We had T right here at negative 6, 1, and now T prime is at negative 6, negative 1. And we had R at negative 4, 5, negative 4, 5, but now R prime is at negative 4, negative 5. So do you see what happened? You'll notice all the x values stayed the same, but all the y values became the opposite. So when you reflect over the x-axis, your x stays the same and your y becomes the opposite. Now notice I didn't say the negative. It becomes the opposite because 5 became negative 5, 3 became negative 3, and 1 became negative 1. But if this was negative 5, that would become positive 5. If this was negative 3, it would become positive 3. And if this originally was negative 1, it would have become positive 1. So we're reflecting over the x-axis. For any point on the triangle, x stays the same and y becomes the opposite. And that's our rule for reflecting over the x-axis. Okay, let's take a look at the slopes of these guys. So let's take the slope of, let's go with RT, and we go 1, 2, 3, 4, run 2. So that's 4 over 2, which rise 4, run 2, which reduces to 2 over 1, or simply 2. Well, let's take a look at R prime, T prime. Well, that would be down 1, 2, 3, 4, run 2. So negative 4 over 2, which equals negative 2. So you realize the slopes become the opposite. Let's take a look at RS. Okay, RS, you're going to go down 2 and run 1, 2, 3, 4, 5, 6. So minus 2 over 6, which reduces to negative 1/3. Well, what do you think R prime S prime slope is going to be? Well, r prime, s prime, you go up 2/6, which means positive 1/3. So hopefully you can see when you reflect, your slopes become the opposite. And just for good measure, TS, you go up 1, 2, and run 6. No, let's count them. 1, 2, 3, 4, 5, 6, 7, 8. So the slope of TS is 2/8 or 1/4. I'm betting T prime S prime is negative 1/4. Let's check it out. We're going to go down 2 and run 8. So it would be minus 2, 8, which in fact reduces to negative 1/4. So when reflecting across the axis, the slopes of the corresponding sides are the opposite. Opposite. Okay? So this says, what is the length of RS? So we're going to find the length of RS. So I'm going to remember we would use the distance formula here. So the length of RS would be, I'm going to cheat, they're over here. RS, it's -4 minus 2 squared plus 5 minus 3 squared. Okay, well that's -6 squared is 36 plus 2 is 40. So the length would be 2√10. That's the length of RS. Well, what's R prime S prime going to be? Well, let's see. I think you already know. R prime S prime is right here, so it's -4 minus 2. And let's see here, -4 minus 2, so R prime -4. Yeah, minus 2, okay, squared plus -5 minus -3. Here you can see the y values both change, so what we're going to end up is the same. This is still -6 squared is 36, and this becomes -2 squared, which is still 4. So we end up with the square root of 40, which is 2√10. So you can see these guys are the same. Okay, and if we did this for all of these using the distance formula, you would find that they're all the same. I'm not going to do that just because keep this video a little shorter. So the length of the corresponding sides of the pre-image and its image are congruent. That's what rigid motion means. The lengths of the sides do not change. Okay, let's do another one. This one I think we're going to reflect across the y-axis. So if you remember, when we reflected over the x-axis, the x stayed the same, but the y became the opposite. So hopefully you can figure this out. When we reflect over the y-axis, the x is going to become the opposite, and the y is going to be the same. So in this case, 5 becomes -5, the x becomes the opposite, and the y stays the same. The x becomes the opposite, and the y stays the same. The x becomes the opposite, and the y stays the same. So u prime is at -5, 6. And you can see its horizontal line would draw straight over there. V prime is at -1, 2. And again, you can see that it's horizontally right across. And -3, this is y prime is at -3, -4. And again, you can see a horizontal line could be drawn. And just to save a little time, I'm going to go ahead and freehand it here. Okay, so we're reflecting over the y-axis for any point on the triangle xy becomes -x, y, but really what we want to say is the opposite of x, y stays the same. A reflection is rigid motion and preserves size and shape. Okay? Okay, and the slope of, let's take VU is 1, 2, 3, 4, 1, 2, 3, 4. So the slope of VU is 1, and the slope of V prime U prime is going to be down 4 over 4, or negative 1. The slope of VW is down 1, 2, 3, 4, 5, 6, run 2. So negative 6 over 2, or negative 3. Slope of V prime W prime is up 6 over 2, 6 over 2, or positive 3. So you can see anytime we do a reflection over the X or Y axis, these slopes become the opposite. When reflecting over the axis, the slopes become the opposite. Okay? That's true for whether you're reflecting over the x-axis or the y-axis. Okay, last one here. Reflect quadrilateral EFGH over the x equals 1 line. Okay, so this is one where we cheat a little bit. We're just going to count. The rule is a little bit trickier, and we're going to hold off on that. So all we have to do, we're reflecting over the x equals 1 line, which is right here. So to find f prime, it's 2 to the left, so it's going to be right there, f prime. And E is 1, 2, 3, 4, 5 to x equals 1, so 1, 2, 3, 4, 5 away from x equals 1. G is 1 away from x equals 1, so it's going to be 1 away from there, and that's G prime. And H is 1, 2, 3, so 1, 2, 3, H prime, E prime, and F prime. And if we draw it, you're going to see the quadrilaterals are congruent, same size and same shape. Okay, so E prime is at negative 1 from the axis now, 1, 2, 3, 4, 1, 2, 3, 4. So it is at 4, 4. Whereas G prime is at 0, 1. And let's see, F prime is at, remember from the axis, not this line, from the axis, negative 1, 1, 2, 3, 4, 5, 6. So negative 1, 6. And H prime is at, from the axis, or the origin, negative 2, negative 3. Okay, so this is a vertical line, okay? So you can see that our y values are not changing, because when we reflect over a vertical line, the y values stay the same, but our